Ah, hello there. You must be here to learn about standing waves. Well, you've come to the right place. Because today we're going to be going through standing waves on a vibrating string and the Rilke tube. So, let's get started. Max, talk us through stationary waves on a vibrating string.
The vibrating pin at the right of the image sends a transverse progressive wave down the string to the boundary at the other end. A weight is attached to this, creating a tension and a boundary. The boundary means that the waves are reflected back down the string towards the vibrating pin from which they originated. This causes interference between the outgoing and the returning waves. The waves have the same frequency and the same wavelength. This interference is in different areas, constructive and destructive. This is why we see points that are stationary and some that are moving. The points that are stationary are called nodes, and the points that vibrate at the maximum amplitude are called antinodes. All points, therefore, that are on the one side of the equilibrium position have the same direction of motion.
Thank you, Max. Now, onto the Rilke tube.
Yeah. 3, 2, 1. Goodbye.
So, how can we explain this using our knowledge of standing waves? Well, let's go to Max and find out.
The sound comes from a standing wave, which has a wavelength that is twice the length of the pipe. This produces the fundamental frequency. The fundamental frequency is defined as the lowest frequency of a periodic waveform. The flow of air past the gauze is a combination of two different motions. The first is an upward motion of hot air due to convection and the Bunsen burner heating the gauze, which in turn heats the air. The second is motion due to the sound wave, which is a longitudinal waveform. For half a cycle, air flows into both ends of the pipe until the pressure achieves a maximum. Then, for the other half of the cycle, the air flows out until the pressure returns to a minimum. Just before the pressure reaches a maximum, cool air flows past the gauze, causing a sudden increase in pressure. Therefore, the sound wave is reinforced once every vibration cycle and quickly builds to a very large amplitude. Hence, there is no sound when the gauze is in the upper half of the tube, since the cool air only reaches it at the end of the vibration cycle.
So, that's it for standing waves. Thank you for watching.